Okay, alright, we got a new video. So today I'm going to be talking about rational expressions. Well, I'm not going to be, it's not algebra, it's more graphing. We're going to graph them. Yeah, so I got a few examples, 3 examples for you, and I know on this right hand side I got everything you need to know about graphing these things. See how to find what these guys are: vertical asymptote, horizontal asymptote. We'll go over them, and then the 3 cases to find your horizontal asymptote. You will need them, and I know they're a little bit. So case number 1, case number 2. And case number 3. So that's that, and then the last part, I know, it's a little intimidating, but I will make it sure. I just wrote everything down. This is basically how to determine if a rational graph has a hole instead of an asymptote. And this is just very long, I know, but I will shorten, I promise you, and this is just a little tip. So that's it. And it's going to be very easy in the beginning, just the last one that's going to be a little more challenging, and that's it. So don't worry at all. Okay, so our first example, actually I'll go over these rules first. Not all of them, just the beginning, what we have to do. So when I write VA, that means a vertical asymptote. A vertical asymptote, I will give you an example, looks something like this. It's usually a dotted line that looks like that. This determines what does that say? Well, this is what value of x will make the denominator 0. Okay, and that's straight away, jump into our example and do the vertical asymptote. So let's look at this one, 2 over x, okay? Let me just write, what is the vertical asymptote? Well, the vertical asymptote, like we said, is what value of x will make the denominator 0. Well, what does x have to be to make it 0? 0, right? There's nothing else you can do. Just if you plug in a 0, you'll get a 0, and we don't want that because 2 or any number over 0 is undefined. It's bad. So the vertical asymptote is going to be, x cannot be 0. Okay? And right away we just plug that. Well, maybe I should use a different color, but this is the whole x. This is x, right? This line is x, but 0 would be right here. This would be negative. This would be -1. This would be -2. This would be -3. But we have 0. So this whole 0 number on the x-axis. The graph cannot touch this line. That's ultimately what vertical asymptote means. The graph, however it looks, it can never go like that. It can never go through this line or even touch it. Just gonna come close. Somehow you'll see how it looks, how it will look. So we know that the vertical asymptote will be at 0. Okay. Now, there's this other thing called the horizontal asymptote right here. So it's basically the y asymptote. So we did the x, what x can't be. What about the y? Well, I know this is the y line, but this is a number on the y-axis. If I do a line like this, this is a number on the y-axis, so it looks like this. Okay? So what number in this function cannot be from the y numbers? Okay, so to find that number, you have to check for degrees in our functions of the variable, of our x. So if the degree on the numerator, I hope you know the degree is the you know, those exponents above the variables. Those, if there's just an x, then the degree is 1. If there is nothing, just a number, like a 4, and nothing else, that means the degree is actually 0. Okay? So just remember, the degree of a constant is 0. Okay? So if the degree on the numerator is smaller than the denominator, then the horizontal asymptote is 0. Always. It's just this thing you have to remember. So like here, since on the numerator the degree is 2, and in the denominator it's 4, that means 2 is obviously smaller than 4, meaning the horizontal asymptote will always be at 0. Okay? Well, let's look at our case first. I don't want to go over all of it because I got examples that deal with each of them. Okay, so let's look at this. What is the degree? What is the degree of the numerator? Well, like I said, the degree of a constant is always 0. So just imagine this like that. Okay, 2x to the 0th power, well, that's 0, right? The degree is 0. We're looking at the degree. What is the degree of this? That's 1. Okay, so we got the numerator's degree is smaller than the denominator. Which case is that? Well, it's the first one, right? So if the degree on the numerator is smaller than the denominator, then the horizontal asymptote is at 0. So this concludes that our horizontal asymptote will be at 0. If this is smaller than the denominator, it's always 0. So horizontal asymptote, you have to put should have done this. Y cannot be 0. Okay? So now, after getting our vertical and horizontal, let's just plot the horizontal. We got the vertical. I'm not going to change the color because it's right there. I hope you can see it. So the horizontal asymptote is also 0. Alright? And now, all we gotta do, since we know these two pieces of information, all we gotta do is plot points. So let's get our handy table of values. I love this guy. He is my best friend in mathematics. Okay, so you have to plot points, but you cannot plot 0, because if we plug in a 0, well, 2 over 0, it's undefined. We cannot have that. So anything close to 0, not 0. So let's start with negative to positive. Let's do a -1, 2, -1. We're going to skip 0, do a 1 and a 2, and maybe a 4. Alright, if I plug in a -2, so our function is 2 over x, if I plug in a -2 in here, well, 2 over -2, it's going to be -1. Alright? If I plug in a -1, 2 over -1, that's -2. If I plug in a 1, that's going to be 2. If I plug in a 2, it's going to be 1. And lastly, if I plug in a 4, 2 over 4, that's 1/2. Okay, and all we gotta do is plot these points quickly. So I got -2, -1, -1, -2. I should have actually picked a -4 here because I did a +4, so I'm gonna do a -4 too. If I plug in a -4, pretend this is another x, and this is gonna be our y. If I plug in a -4, I'm just gonna get a -1/2. Okay? So if I do 1, 2, 3, 4, I'll get -1/2. Okay, let's continue with our positives now. So 1, 2. 1, 2. Next one's 2, 1. 1, 2, 1. Next is 4 1/2. 2, 3, 4 1/2. Right here. So you can continue. I mean, pick numbers from pick a 6, pick an 8, pick anything. And same here, pick negative numbers that are the same, so it'll be even. And you will get something looking like this. Yeah, not a great job, but you get the idea. It's just tangent to both the asymptotes. Okay, there you go. Wow, I am a terrible drawer. There. So we said the asymptote is at x equals 0 and y equals 0. Well, look at this is half of the graph, right? So a part of the graph is coming close to our first asymptote at x not being 0. So it's not touching our first asymptote. And look at our second part of our half graph. It's not touching our other asymptote, which is y equals 0. And same with this. It's close to the x equals 0, but not touching. Same with the other part. It's close to the y equals 0. So they are both they don't have to be connected. They're the same part of the graph, they're the same function, but they don't have to be connected in any way. So that's how it looks. Alright, let's jump into our next example. Okay. So we got 2x over x minus 4. Alright, so let's do our vertical asymptote and our horizontal asymptote. Okay, so a vertical asymptote is, remember, what value of x will make the denominator 0. So if you have just an x, that's easy, that's 0. But if you have something, if you don't see it right away, you can just do x minus 4, take this, and set it to 0, and then solve for it. Then you will see, you will get x equals 4. And if you put this line, meaning x, this means that x cannot be 4. And it really makes sense, because if you plug in a 4 in here, 4 minus 4 is 0. Well, we cannot have a 0 in the denominator. So our vertical asymptote is x equals 4. Which makes the denominator 0. And now our horizontal asymptote. So remember how to find the horizontal asymptote. We have the 3 cases, but right now let's first determine our degrees. Okay, what is the degree of this of the numerator? Well, it's 0, right? Again, it's just x to the 0th power, so it's 0 over, what is the degree? Well, it's 1. So we have the same case as we had in our first example. And remember, if the degree in the numerator is smaller than the denominator, that means the horizontal asymptote will be at 0. Okay? I just want to practice this one again with you, so it really would make sense. So y cannot be 0 and x cannot be 4. Okay? And right away, let's just plot the points. So we got x cannot be 4. 1, 2, 3, 4, 5. And 0. Well, the 0 is right there. There. Okay? And the last step is just plot points. That's all. So let's see, since this line right here is like our y-axis line. yeah, the y-axis. It's just moved over 4 units to the right. You can think about it that way. So if our vertical asymptote would be at 0, we would pick numbers that are relatively close to 0, like 1, 2. Here, because our asymptote is at 4, we want to pick close numbers to see what's going to happen to our y, our f of x. So if we pick a 3, let me pick a 2 first. This one. Or, yeah, let me pick a 2. Then I'll pick a, no, we can't. Yeah, sorry. Then I pick a 3. We can't pick a 4 because 4 is what makes the denominator 0. It's our vertical asymptote. Then I'll pick a 5. And I'll pick maybe a 6. Maybe an 8 as well also. Okay. So if I plug in, where am I? Yeah. If I plug in 2 into our function, 2 minus 4, well, that's negative 2. 2 divided by negative 2 is negative 1. 3 minus 4 is negative 1. 2 divided by negative 1 is negative 2. 5 minus 4 is 1. 2 divided by 1 is 2. 6 minus 4 is 2. 6 minus 4 is 2. 2 divided by 2 is 1. 8 minus 4 is 4. 2 over 4 is same thing as 1/2. Okay, perfect. Let's graph. So we got 2, 1, 2, negative 1. We got 1, 2, 3, negative 1, 2. We have 5, 2. That's not too good. We have 5 right here. Oh my. 5 and up 2. We have 6 and 1. And 8, which is probably right here. 1/2. It's pretty small. Okay, I could have picked a negative 8 as well to see, but it'll be probably, very small. My pen is not doing a good job. But anyway, our graph, you can do the more numbers if you would like, but our graph, that's not a pretty curve, is it? Our graph will roughly look like that. Okay? So there you go. It's the same picture, it's just the asymptotes change the values. Alright, now that we got this, we're going to move on to something a little bit different. Okay, this is a little different, but you'll see what, I don't want to spoil it for you, but there is something we will need to read. I know, it's scary, but I'm not gonna make you read all this, don't worry, I'm just gonna explain it on the way. Okay, when we look at this, what do we think? Okay, if we would just do it our normal way, for a vertical asymptote, we would be thinking, well, what can x be, which makes the denominator 0? Well, negative 3. The problem is, we can't do that. Because if we look at our numerator, you might be thinking, hopefully you're thinking, this could be factorable. Can it not? Well, let's see. Let me just erase this for a sec. It can. Alright? So if we do factor this, what do we get? Well, we get x plus 3, x plus 2, divided by x plus 3. Well, we can obviously cancel these out, and we are left with, this is all f of x, we are left with x plus 2. Oh no! Our denominator is gone. Remember, we determined our vertical asymptote by looking at our denominator. We think, what can x be in the denominator, which makes it 0. It's negative. But now we don't have that anymore. So we don't have, this means if you are able to cancel your denominator out, that means there's no vertical asymptote. Okay? I know it's a little bit, okay? But that's what it really means. If it cancels out, then your vertical asymptote, it's gone. We don't have anything. Because we really don't have anything. We canceled it. Alright, so we're left with, but hold on, I'm not done yet. There is a little trick that you have to know. But we'll get to that in a minute. We got x plus 2. Well, what is that? That's a linear graph. It's fairly easy to graph, right? You just have the y-intercept at 0, 2, 0, 1, 2. And then all you gotta do is, it's not too good. No. It's just a line. Is that even? I don't know. But, no, it's not. It's just. But, we have a, no, I should have done that because I need to explain one more thing. I'm going to graph just this part for now. Okay? Because there was some, okay, so let's say we graph it. But we still are graphing this thing, right? We're still graphing this. Just because we simplified it doesn't mean it's gone. Okay? The problem with this is we have, instead of a vertical asymptote, we have something called a hole. We have a hole. This hole is still what x can't be. Alright? Whether we have an asymptote or not, our function still can't be 0 in the denominator. Okay? If we would have if we haven't have cancelled it out, I don't know if that makes sense. If we wouldn't have cancelled it out, there you go, then we would have vertical asymptote. But since we cancelled it out, we have a hole. Okay? So it's a little bit, it's something you have to get used to. But just remember, if you cancel, you have a hole. If you don't cancel, you have the vertical asymptote. Alright? So, what makes the denominator 3? 0. Well, it's negative 3, right? Negative 3 plus 3, that's 0. So our hole will be negative 3. Right? But what's our f of x? What's our y value? Well, to get your y value, all you gotta do is plug it into our function. This is our function. This is just our simplified function. Right? What we graphed. We need to plug it into here. If you plug in negative 3, you get negative 3 plus 2, which is negative 1. So this hole is also called the point of discontinuity. Alright, so our point of discontinuity is at negative 3, negative 1. Well, where is that? Negative 1, 2, 3. Well, I'll make it here. 1, 2, 3, negative 1. Okay? Oh, I'm not supposed to do that. You're supposed to actually draw a hole. You see, my graph is terrible. But we forgot to do something. And I know it's totally my fault. I forgot to talk about the horizontal asymptote. Right? I'll fix that in a minute. But we did the main thing. The horizontal asymptote, we know how to do that, right? We look at the degree. So you have to look at your highest degree. Okay? See in here you got x squared and an x. Which one's the highest one? Well, it's the x squared, right? So you look at your highest, which is x squared, so the degree on the numerator, is 2. And the degree in the denominator is 1. Ooh, okay. This one's a little different. Well, let's look at our rules. What happens if the degree of the numerator is bigger than the degree of the denominator? Let's see. So, let's look at this one. So, if the degree on the numerator is bigger than the denominator, then there is no horizontal asymptote. Okay? So, this means there is no horizontal asymptote because 2 is obviously bigger than 1. Great. Nothing. Or okay, whatever. Yeah. So that's all. You know what? I can't stand this. I'm so sorry, but I just see all these lines bother me. They drive me crazy. No. So that's it. We have our hole at -3, -1. This is the point of discontinuity. And yes, that's it. So this one was a little bit challenging, but hopefully you understand how to deal with them. So I left a little tip. So before you start any, like if you start something like this, if you're asked to graph something like this, I mean this one's pretty simple. You don't need to check anything if you have a hole or nothing. You can just find your vertical and horizontal asymptote, graph it right away. But if you have something like this or more examples that we will do later on, my tip is to check if you're working with a hole or an asymptote by looking to see if your function is factorable. Okay? So just check right away, usually it's in the numerator. Check if this is factorable, you can do something with it. If you can, don't jump into conclusions. Factor first. See if your denominator cancels. If it cancels, that means you have a hole. You have a hole. Alright, and then graph what you are left with. But while you're graphing, keep in mind that you are graphing you're still graphing the original. You have to honor this, our original graph. And to honor it, you have to make sure you get that point, which makes this denominator 0. And keep in mind that if it cancels, if the denominator cancels, there is no more vertical asymptote, there is a hole. I just said that. Okay. And to find, if you found your x value for your, because you know that -3 plus 3 is 0, so -3 is your x value. To find your f of x, your y value, just plug it into your simplified version of this function. Excuse me. Plug it in, find your y value, and mark it on the graph. Okay, this video is definitely too long. I will probably do much more examples because there's another case that we didn't go over. And I hope I didn't confuse you. I probably did, but I hope you don't blame me. But yeah, I'll see you in my next video.